Hello everyone, welcome again. In this video, I'm going to explain about network devices. So this is the agenda. So we're going to discuss about repeaters, hub, switch, bridge, router, gateways. Yeah. So these are the main devices used in a network or when you are communicating with other party using Ethernet. Okay. So the first device is repeater. Okay, as the name suggests, it will just regenerates the signal to reach the longer distances. Okay, so it works at physical layer of the OSI layer. Okay, it will not work on the higher layer data. Okay, like data link layer, network layer. Okay, it will deal with the only physical layer uh, data. Okay, so it will not amplify the data, but instead it will copies the incoming bits and then it will regenerate those bits with the same amplitude. Okay, it is not like the incoming signals are amplified, but it will copy the incoming data and it will regenerate them with the same amplitude. Yeah, it's a two-port device. Okay, one is input, another one is output. Okay, so the next one is hub. Okay, so it is similar to a repeater, only difference is it will be a multi-port one. Okay, so we can say it's a repeater with a multi-port. Okay, it's connects wires from multiple devices. Yeah, so it also works on the physical layer. Okay, so it cannot filter the data, sends frames to all connected devices. Okay, so the hub will not be having capability to filter any frame coming into the ports. Okay, whatever it receives on one port, it will just distribute that packet to other ports here. Okay, let's assume data is coming in this port. It will just distribute that data to all other ports. Okay, so there is no filtering happening in this hub. Okay, it is similar to repeater. The third device is bridge. Okay, so as the name suggests, it bridges the two LAN networks. Okay, so the main features are it is a two-port device. We will be having two ports. Okay, here you see this is one port and this is another port. Okay, so the bridge basically used to divide two LAN networks. Okay, or to connect two LAN networks. Okay, so here you could see in the diagram we have one LAN network. Okay, here and another LAN network here. Okay, so we are just showing here two nodes here with a MAC and PI layer. So it's a data link layer. So just assume that it is one network and here we have one more network. Okay, so both the networks are connected using a bridge. Okay, so here you could see the bridge is having it is working at the MAC layer. Okay, so it is not at the physical layer, it is working at the MAC layer. Okay, so that means it has access to MAC addresses. Okay, and it can support the filtering options. Okay, so it can filter the data. Okay, let's assume I want to send some data from this network to this network. Okay, so if other node, the receiving node, if it is residing in other network, then only the data is transferred from this bridge to other network. If the intended receiver or the MAC in this transmitting frame, if it is not matching, then it will not transfer that data to another network. Okay, so it divides the collision domains into two. So let's assume if you have more nodes in single network. Okay, so then the data transmitted by each node and the frames collision rate will be higher. Okay, so if you have a bridge in between, okay, so the data transfer from to other node, it will be restricted. The intended frames only will be transferred from one network to other network. Okay, so that means the collision domains are divided here. Okay, and the next point is it is implemented at the software layer. Okay, it is not at the sorry, it is implemented in the software level. Okay, not on the hardware level. Okay, so the bridge properties are like it's a two-port device. Okay, and it works on the data link layer. That means it can filter the MAC addresses. Okay, and it divides the collision domains. Okay, so it avoids the collision. Okay, it reduces the collision of the frames in the network. So next one is switch. Okay, so switch device also works in the data link layer. Okay, so data link means what we have, the main properties MAC address. Okay, so MAC address, this also works at the data link layer and deals with the MAC addresses. So switch is a multi-port bridge with buffer. So as we saw in the bridge, it is a two-port device. Okay, switch is a multi-port bridge. Okay, so it will be having multiple ports as we saw in the bridge. Okay, so it has error checking before forwarding the data. Okay, what switch does is, so whatever data it comes, so it will learn its port. Okay, it's a switching table. Okay, so it will be having IP and sorry, not IP, the MAC table. So whenever it receives some data, it will check to which port it has to be forwarded or a network. Okay, so then only it will just switch that data, coming data, to the intended port or a network connected network. Okay, so and one more feature is like it can perform errors checking. Okay, before forwarding the data, let's assume if it is receiving a frame which is having CRC error. Okay, so if it is having CRC error, it will not be forwarded, it will be just dropped at the input port itself. Okay, so the implementation of switch happens at hardware level. Okay, so here also you could see um, a switch, it will be having a pi. Okay, it's nothing but the hardware level, it's a port level, and then we have a MAC. So that means MAC is common for all the ports. Okay, and it is having different pi for different ports. Okay, so whenever a node is sending data to other node, so let's assume this is like node, first node with ending MAC address 01. Okay, so if this node wants to send some data to node 3. Okay, so the with the MAC address 03, ending with 03, so the data will transfer, I mean, come here as an input port. Okay, so switch will be already learned. Okay, it will be having a MAC address table, and it will send the incoming packet to this port by checking the destination MAC address. Yeah, so if it is like sending to this node, it will see the destination MAC address as 03, and it will switch to this network. Okay, let's go to the next slide. So next one is router. It's a very important device. Okay, so uh, it works on the network layer. Okay, so when we see network layer, it always deals with the IP. Okay, that means it is one layer upper. Okay, that means it has to look into the network layer data as well. That means it has to receive the data and it will unpack it to the network layer, until network layer, to see the IP address. Okay, so depending on the IP address, it will switch the routing. Okay, so it is also like a switch routes the frames based on their IP address. Okay, not based on the MAC address, but um, based on the IP address. Okay, it will decide to which port it has to be routed. Okay, so the router will be having dynamically updating routing table. Okay, routing tables are nothing but the connection paths. Okay, let's assume we have multiple nodes in the network. Okay, so we have A, B, C, D, E. Okay, so let's say I want to send some data to E. Okay, so which path is faster? Okay, so let's say if I send data via B, okay, will it be faster, or if I send data via C, D, E, will it be faster? Yeah, the faster connections will be saved. Okay, so as a routing table. Okay, so simply just remember them as a connection paths. Okay, so routers are mainly used to connect LANs and WANs. Okay, so since it deals with IPs, if you want to connect to internet, so you need a public IP. Okay, so there are again concepts like private IP and public IP. So you need public, I mean, sorry, a translator. Okay, so your private IP has to be mapped to a public IP. So the router will come into picture where it will be having a routing table. So let's assume this is a router, and down you have a private network, maybe private IPs, I could say. Okay, at the other end it is connected to internet via public IP. Okay, so this translation will happen over in the router. Okay, so here you could see in the diagram, the first node is sending data to a router. Okay, it will see over here, let's see, yeah, it go to this router, it will check the MAC, okay, and check the IPs. Depending on the IP, it will send the data to next router. Okay, next router will check the IP, MAC address and IP, and then depending on its connection path, it will send to next router and then to the destination node. Okay, so I will explain in some of the videos how this routing will happen with an example of IP and MAC. Okay. So the last one is gateway. Okay, it's a very high-end device in a network. Okay, so it is basically used to connect two networking models that operates on different networking models. Okay, so let's assume you have two networks operating in two different physical media. One is operating at OFC, fiber optical cable. Another one is operating at telephonic wire cable. Yeah. So to transfer this data to two different media, or else different speeds also. Okay. One network is operating at 100 Mbps. Other network is operating at different speed. Let's assume higher speed, 1 GB. So to map, to match or to sync these two network, okay, we need gateways in between. Okay, so gateways will be having more complex softwares or algorithms. So to translate or to map this to different networking models. Okay, so it is more complex than switch or router. So protocol translators. Okay, so different protocols, let's assume I'm sending some data. One network is working using IPv4, another network model is working at IPv6. So the protocol translators, okay, how to translate this data, impedance matching, okay, and rate converters. Okay, impedance matching will come into picture when you have two different networks with different speeds. Okay, so impedance has to be matched. Okay, um, rate converters are nothing but the speed. Okay, and basically gateways are used in proxy servers and firewall servers. Okay, so this is about gateway. So here in this example you can see we have two networks here. Okay, so let's assume this is one network. Okay, and this is another network. Okay, so connected to switch via hub. Okay, hub is working at a physical layer. Okay, it will just transfer the data received on one port to all other ports. Okay, so two networks, okay, are connected using routers here. Okay, so you can just imagine how the devices are used. Okay, and if you want to connect two networks, okay, then bridge will be used. Okay, it's as if there is no routing will be happening, but it is like MAC filtering will be happening. So if one node wants to send to this node, um, then only data will be transferred from this bridge wire to other network. Okay, if this node wants to send some data to this node, then that packet will not be received by these three nodes in other network. Okay, so that means data will be just traversing in this network. It will not come to this network. By reducing that frame flow, we can avoid the collision. Okay, so this is the device usage in a network. Yeah, so that's all for this video. If you have any questions, please reach out to me. Yeah, thanks for watching video.